So another thing you're going to need to know is if you are given a number in standard form or scientific notation, such as these here on the screen, how would you turn that back into a decimal number, back into a number in its written out longhand, if you like? Let's have a look at this one. 6 times by 10 to the 5. We would, in fact, I'm just going to write in there 6.0 times by 10 to the 5. That's scientific notation. We know it is because our leading number is 1 or more and it's lower than 10. And then we multiply that by a power of 10. But what does that actually mean? 6 times by 10 to the power of 5. Well, it means 6 multiplied, and I'm just going to write this one out longhand, 6 multiplied by 10 5 times, 10 5 times. That's by 10, 10, by 10, times by 10. That's all that number means. Well, 10 times by 10 times by 10 is 1,000, times by 10 is 10,000, times by our final 10 is 100,000. So what we're actually writing there is 6 times by 100,000, which we know is 600,000. So we've easily converted now from our standard form into a decimal notation. So what about this example? Same thing, except we've now got something after the decimal point, 7.8 times by 10 to the 4. Again, if we think what that means, it means 7.8 times by 10 4 times. There we go. And what it can really help to think, it can really help you to think with these is to think, right, how many of these tens do I need to use in order to deal with the fact that I've got this decimal here? I've got something in the tenths column. And how many of these multiplied by 10 operations do I need to use to get rid of that? Well, in this case, because I've only got a 0.8, I've only got one decimal place, I only need to use one, because 7.8 times 10 is 78. Now we've dealt with that one, and that's 78 times by 10 times by 10 times by 10, which is 1,000, 78,000. Okay. That's quite a longhand way of doing this, and you'll find as you do more and more, actually, you'll start missing these steps out. And you don't always need to be writing every step, but it's really useful for you to think through in this way when you're getting used to converting out of standard form. Okay, so in this case, we have got 3.825 times by 10 to the power of 8. I'm not going to write this one all out because, as you know, 10 to the power of 8 is 10 times 10. It's times 10 8 times. 10 times 10 times 10 times 10. And on it would go. So I need to think, just like I did here, how many of those times by 10 operations would we need to use to change this decimal number into a whole number, into an integer? Well, if I multiplied it by 10, then I'm going to end up with 38.25. Multiply it by 100, I'm going to get 382.5. So if I multiply that by 1,000, then I'm going to get 3,825. And what I've just done there, all I've done is I've multiplied by 1,000. So 1,000 is 10 to the power of 3. So I've used up some of my powers of 10 here, and I need to think how many I've got left. I've multiplied by 10, multiplied by 10, and multiplied by 10. I've multiplied by 10 3 times, but I had 8. So actually that's 3,825 times by 10 to the power of 5. I've still got 5 left, so I need to put on 2, 3, 4, 5 more zeros on the end. And if we put some commas in just to make this very long number a little easier to read, we can see that we've got 382,500,000 converted into a longhand decimal number.
Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.